we're going to get started with back to the basics of PyTecplot. Today on the call, myself, Scott Fowler, I'm the Tecplot 360 product manager. So I also manage the kind of halo of tools around Tecplot 360, such as PyTecplot, which you'll be learning about today, Tecplot Chorus, which we'll introduce briefly, and Tecio, which is a library for exporting Tecplot binary files for reading into Tecplot 360. I'm joined today by Jens Varkal, who is from our German office, and I'll have you give a brief introduction of yourself, Jens.
Yeah, thank you very much, Scott. So I'm Jens Varkal. I'm a senior technical consultant. I'm working for Tecplot Europe since 17 years now. And in short description of my job is that if you don't have a license of Tecplot, then I try to convince you from the product. And if you have a license, then I want to make you happy to be your happy customer. That's basically my job description.
Okay, great. Thanks, Jens. So we do ask that you participate in the webinar today. There is a question and answer pane. I see somebody's already found it today, and Jens is going to be on hand to answer questions there. So please do ask questions during the webinar, and Jens will take the time to answer those. Also, we'll have time at the end of the webinar, and we'll take the questions and answer them verbally as well. This webinar is being recorded, so if for some reason you have to get pulled away out to a meeting, there will be a recording of this distributed to all registrants. So for those of you that may be new to Tecplot 360, or for those of you who have used Tecplot for a while, I'll just give you a reminder here of who we are and what we do. So Tecplot was founded in 1981 by a couple of Boeing engineers. They were writing CFD codes at the time, and they realized they needed a way to visualize the results from those codes. And so they hired a software developer who's actually still at Tecplot today, so going on 40 years at Tecplot, who really invented the product that you know and love, Tecplot 360. In that time, we've amassed about 47,000 customers worldwide in academic, government, commercial, all areas of engineering. We're really known for being the most complete desktop solution. We have a whole suite of data loaders. We can load lots of different file formats. We have 3D plotting to make beautiful plots like the one that you see on this screen, but also engineering type plots, line plots and 2D contour plots, very important to making engineering decisions. And we're dedicated to saving you time. So how do we save you time? Well, we invent new technologies like our SZL file format, stands for Subzone Load on Demand. So the image you see on the left here is a visual representation of what most post-processors have to do to create a slice. You have to load the entirety of the volume grid to just create that one thin little slice through your domain, where the Tecplot SZL sizzle file format subsets the grid, and we only have to load the cells required for that slice. And what that does is it saves you time. It saves you RAM, so you get better use of the hardware resources and better use of your own resource, which is time, because you're loading less data, using less RAM, and do faster post-processing. We also have Tecplot Chorus, which is a companion product with Tecplot 360 when you are paying for your Tech Plus subscription. This gives you the ability to understand ensembles of data. So if you're doing aero databases or design of experiments or trade studies, this is a great tool to help you organize and visualize your work. So if you're doing hundreds or thousands of CFD runs and want to aggregate all of those results and look at them in one product, Tecplot Chorus is the right tool for you. We just did a webinar on Chorus last month or 2 months ago, so please do take a look at that. And then automation. We have 2 scripting layers to automate Tecplot 360, and so that's our macro language and our Python language. So you can see some Python code here, and that's really what we're going to be talking about today, because to really take advantage of Tecplot 360 and take advantage of your time, you're going to want to get work done while you're sleeping. So automation can really help with that. Batch automation is a great way to speed up your processes. All right, so let's dive into the meat of today's agenda. So we're going to be talking about PyTecplot. We're going to start with a brief description of what PyTecplot is and why you might want to use it over the Tecplot macro language, or why you might want to use the Tecplot macro language instead. We'll talk about PyTecplot installation and some of the little gotchas that you might have there. We'll talk about connected versus batch mode. So batch mode is going to be running PyTecplot completely in batch from a command line without a GUI. Connected mode actually uses Python to drive the Tecplot 360 interface, and we'll demonstrate that. Recording and playback. So just like Tecplot macros, you can record Python, and we'll show you how to do that. Modifying your recorded scripts. The recorded scripts are pretty verbose because they record everything that you do. We'll show you how to do some modifications in there. We'll talk about best practices and introduce you to our GitHub repository, which has some handy Python scripts that you may be interested in. All right, so first subject, PyTecplot versus the macro language. So the Tecplot macro language was invented back in the 80s when Tecplot 360 really got started. So it's our own proprietary language, and it's incredibly useful. It's built right into Tecplot 360. It's pretty easy to use. We have good documentation around it, but it's not quite as powerful as PyTecplot. And Python, our PyTecplot layer gives you direct access to the data and data manipulation, so you can do advanced analysis. The Python language gives you things like string processing, logical operators, loops, file system access. So all of this power of Python coupled with Tecplot 360 is pretty amazing. Integration with other Python modules such as NumPy and SciPy. We have some examples of how you can use those modules for array manipulation or additional statistics calculations. And then one of the really big ones is being able to use any Python IDE for debugging. So IDE is integrated development environment. So if you're familiar with Python, you have really great debugging tools available that we just can't effectively build ourselves for the macro language. So the macro language, again, is great for simple recording and playback within Tecplot 360. It's very simple to register a Tecplot macro in what we call the quick macro panel for easy access. But you also have limited debugging options and not nearly as much of the power that a true API like Python gives you. All right, so what are some of the requirements for PyTecplot? So one thing to keep in mind is PyTecplot is a separate installation from Tecplot 360. So just because you've installed Tecplot 360 does not mean that you have PyTecplot. You have to install it separately. So before you install it, you have to make sure that you meet a couple of requirements. Tecplot 360 2019 R1 or newer. And we state that because that's our oldest currently supported version of Tecplot 360. PyTecplot will work with earlier versions, but those versions are no longer officially supported. You need a 64-bit version of Python. You need Python 3.7 or earlier or later, rather. It may work with earlier versions of Python, but again, those are no longer supported. So we endeavor to or we test against the current release of Python. So that's Python 3.9 right now, and the two Python releases prior. So that's 3.7, 3.8, 3.9 is what we're actually testing on. So we have tested on 3.6 and earlier in years past. You can see the asterisk at the bottom. We have tested on Python 2.7 in the past, but Python 2 has been support for that has been dropped by the Python community. So again, we're no longer officially supporting that. And to run PyTecplot, it does require a Tech Plus maintenance subscription, which gives you access to not only PyTecplot, but Tecplot Chorus and our great support staff like Jens, who's on the call today. And so installation is pretty easy. It's a simple pip install PyTecplot. So if you're familiar with installing any other Python modules, it's just the same. If you don't have administrator access, you may have to use the -- user flag. And if you've already installed PyTecplot but want to upgrade it, it's just pip install -U PyTecplot, and that will get you the most recent. And with the release of Tecplot 360 2021 R1, we've also released PyTecplot 1.4. So if you're on an older version of PyTecplot, you may want to update. And we have extensive notes for the installation on our webpage, and these documents also get installed with Tecplot 360. So there can be some little gotchas with the Python installation, because this is not a pure Python module. This is a Python module that actually requires the binaries that come with Tecplot 360. So it requires Tecplot 360 be installed on your machine as well. And because we are utilizing libraries which are installed with Tecplot 360, Python needs to know where to find them. It's usually pretty easy on Windows. When you go through the installation, Windows by default will update the path environment variable for you if you don't uncheck the little toggle during the install. If you have unchecked that, you're going to have to make sure the path environment variable is set up, but I think most users keep that checked. On Linux and Mac, you have to set up the LD library path or the DYLD library path on Mac. And let me just give you an example of what that may look like. You can see it in the screenshot. If you don't have it set up right, it'll complain about the library file name. So I'll just give you an example here. So we'll start Python 3, and I already have Python installed, so I'll say import Tecplot as TP. This is kind of the canonical way of referencing PyTecplot, and we'll say tp.version info. So this shows that I have Python 1.3, so I'm a little bit behind on this Linux machine, and then I'll say tp.new layout. So this is going to start everything fresh. And you can see I get this error. So what does this error mean? It means that the Python module couldn't find the Tecplot libraries required to run. So we'll just exit here. And if I go to 360 EX, 360EX, bin, we have a little script in our bin directory called tech360env. I'll do -- Python 3. So what this is going to do is it's going to actually start up Python 3 and set up that LD library path and other environments for me. And then we'll do this again, import Tecplot as TP, and we'll say tp.new layout. And so you can see now no error, and I can say tp SDK version info, and this tells me that I am using the libraries associated with Tecplot 360 2021 revision 1. So it's an important thing to note about the Linux and Mac installations and our relationship to the Tecplot 360 version that's installed. Okay, batch mode versus connected mode. So this is an interesting one. So most Python modules run pure Python. Well, our PyTecplot allows you to not only run pure batch, but you can actually drive a live running Tecplot 360 with Python. So let's talk about batch mode first. So batch mode runs exclusively without a GUI. So this is great if you're running on Linux machines or Windows machines or running on an HPC. You can run completely without a GUI. And one of the really interesting things here is this will check out what we call a batch license instead of a Tecplot 360 GUI license. So when you purchase Tecplot 360 and you have that Tech Plus maintenance subscription, you actually get 3 licenses in one. You get a Tecplot 360 GUI license, you get a PyTecplot batch license, and you get a Tecplot Chorus license. And all of those licenses are checked out individually. So if you're running PyTecplot in batch, it's going to check out that separate batch license, which leaves GUI licenses available for your colleagues. Batch mode is great for image and movie generation. It's great for automated data reduction, great for data analysis. So nice way to use the power of PyTecplot in a completely automated way. Now in connected mode, again, you can drive a live running version of Tecplot 360. So you can access data that's currently loaded, you can change the plot style, you can load data, export images, etc. So let me just give a brief example of this. So I'll bring Tecplot 360 over here, and I'll bring a command prompt over, and I'm just going to start up Python, and we'll say import Tecplot as TP. We'll say tp.data.load CFX, and I'm going to load a file. This is the same file that I'm going to use for a more extended live demo a little bit later. So we'll say load that data file, and it takes a little while to load that data file, mostly because we're getting Tecplot started up. All right, so now I have a data set loaded, and I can say tp.export .save PNG, and we'll just say image.png. So this happened entirely in batch. We loaded a data set and we saved an image. Let me just bring the file browser over here, and I promise you this image file wasn't here just a minute ago. And we'll load this. Of course, it came up on my other monitor, and here's the image. So that happened entirely in batch. Okay, and now we can do this again connected to the live running version of Tecplot 360. So the first thing we have to do is go into the scripting menu, and we'll say PyTecplot connections, and we'll make sure that accept connections is checked. And let's do this again. So we'll say tp.session.connect. Okay, so now this indicates that I have a connection to Tecplot 360 here, and we'll go back up and we'll say load CFX. And you can see it's now driven Tecplot 360, and again, I could do any host of operations. So very quick demo of batch versus connected there, and we'll get more into this later. Okay, so into a real live demo. So we're going to demonstrate a lot of things in this live demonstration. We're going to use this CFX data file, which is a simple blade row, and our goal in this demo is to create a line plot of the integrated temperature or average temperature at various slice locations through this blade row in the axial direction, which is the Z direction here. So this is going to require that we place a slice, we extract that slice, and then we do the integration. And then we're going to have to store that information to create some new data. So this is a way to demonstrate some of the power and the added analysis capabilities that you can realize by using Tecplot 360, over and above just the simple automation of loading data, creating a plot, and saving an image. So in this, we'll talk about recording a script, we'll talk about playback, modifying that script, etc. So again, let's bring Tecplot 360 over here. And let's start with a new layout. So to get me started, I want to record a script. So I'm going to record the actions that I take, and this is a great way to get started with Python because I don't need to know all of the APIs, and it'll give me a hint as to what I really, what APIs to look for. So let's just take over a script that's already here. Yes, I want to replace it. And this launches the PyTecplot recorder. So if you're familiar with recording macros, this should look very similar. And one thing to remember here is that when you're recording a macro, it will record every action that you do in the GUI. So I'm going to be fairly limited in my interactions with the plot while recording this macro. So first thing I want to do is load the data file. Confirm that it's ANSYS CFX, and You see we don't have any plot on the screen. I am going to click redraw just so we can see something here. Now that also recorded a redraw command, which we're not going to need within the when we're playing back the macro. We want to place a slice at a Z location. It doesn't really matter which Z location at this point because when we modify this script, we're going to modify it such that we place slices at various Z locations through this. So let's bring up the slice dialog. We'll select Z planes and we'll activate the slice. And we're going to extract this. Okay, and we'll just go to the dataset information dialog and verify that we now have a new slice. Looks like the slice got put at 0.05. And now we want to integrate the average. So we'll go to the Analyze menu, Perform Integration, Average Temperature. Temperature is down around variable 20. And we're going to select that slice and click Integrate. And this gives us a result just in the dialog here. But this result is actually stored also in auxiliary data. So if we can go to dataset info again, go to aux data, and you can see that that result is stored here. So we'll just have to commit this to memory that we're going to be pulling this result out of the frame auxiliary data. So again, the frame is, for those of you that may not be familiar with the objects in Tecplot, we have a frame. Within a frame, we have a data set, and we have a frame can also be of various plot types. So kind of the main objects are data set, frame, and plot. So we're going to be extracting the auxiliary data from the frame auxiliary data. All right, so let's stop the recording and we'll bring this up in Notepad++. All right, so we can see the recorded script here. It will put some preamble at the top. Again, if you do want to run this script in connected mode, you can uncomment this line. You can see that we have a couple of commands that got recorded. One, the redraw all here, and pick. The pick command happened because I had right-clicked on the data and it brought up the context menu. We don't really need that for our purposes, so we can delete that as well. Tecplot, when first loading data, will set up a number of other variables for convenience. We're not using RGB coloring. We're not using any contour coloring in our script, so we can go ahead and delete those as well. So you can see we come down to a very small number of lines that we really need. And we could just go ahead and play this from the command line, but it's not going to actually do anything on the command line. So let's put it's not going to print any output. So let's print some output. So we'll say tp.active frame aux data, and we're going to do cfd.a.integration total. All right, so let's try running this from the command line and make sure that I got it right. Okay, so the script ran. It performed these operations, loaded the data, placed the slice, extracted it, and did the integration, the integrated average, and then printed the result. So we know that that's right from the command line. Let's just show you again that this works from connected mode as well. So we'll start with a new layout. And we'll go back into Notepad++ and uncomment the tp.sessionConnect. And we'll run from the command line again. All Okay, so you can see that actually interacted with Tecplot 360 running live, and dataset information. We can see that we have the CFDA integration total and we have our extracted slice. So it redid all of those commands. So that's great. It's a good start. But really what we want to do is we want to do this at various Z stations along the blade row, and we want to create that line plot. So let's come back into Notepad++, and we'll just do a little bit additional modification of this short script, and then I'll go into kind of the easy bake oven, and I'll show you what the full script really looks like. We'll dive into some documentation as well. So a couple of notes here. The reading of data sets is kind of a difficult one for Tecplot 360 to really translate from the command that comes into Tecplot to the pure Python loader API. But we do have a loader API for ANSYS CFX. So let's just bring our web browser over here with our documentation. So I'll just type CFX into the search, and it looks like we do have a data loader command for ANSYS CFX. And you can see the only argument that I really need is the file name. Everything else has defaults associated with it. So we'll just change this to tp.data.load CFX, and we'll put in our file name here, and that will replace this entire line. And the load command also returns a dataset that a dataset object. This dataset object will give you access to the set of zones, the set of variables, and from those zones and variables you can access raw data about this data set. We'll do a couple other small shortcuts here just for good practice. So we'll get a handle to the frame, tp.activeFrame, and we'll get a handle to the plot. So this is frame.plot. Because we're using these items over and over again, it actually helps the script run a little bit faster if we use these shorthand notations. And one thing you'll notice here is this uses plot and then open paren Cartesian 3D. One of the things about slices only work with 3D plots. But we happen to know that because this is a 3D data set, that the default plot is going to be in 3D. All right, so just a couple of little updates there. All right, a couple other items here. We want to make this script robust. So we want to make sure that it works with effectively any data set. So if this command right here, the CFDA integration command, this is referencing a hard-coded zone number. So when I extract that slice happens to be zone number 16. Well, if I have another data set that has more zones or less zones, this number is likely to be wrong. So what we want to do is we want to generate this number. So we'll just put a %d in here. And so we're going to have this number be dynamic. And then the scalar variable. So this was variable number 20 was our temperature variable. We're going to put a %d in here as well. And let's just update this line, kind of a long line, but we'll just put zone num here and var num at the end. I think I need a closing parenthesis. Okay, so now this is dynamic, but we need to actually derive that zone number and variable number. So the extract command is actually going to return a set of zones. So if we go to slice extract, let's type extract here, and we can learn a little bit more about about this. So you can see that we have a number of extract methods. This is plot.slices extract, which you can see here, plot slice extract. So that's the one we want to look for. And this one says that it will return a single extracted zone if the mode is set to single zone, which it's not. Otherwise, it's going to return a generator. So a generator is effectively kind of like a Python list. So we happen to know that the way that we're calling this is going to return just a single zone. So we'll get a handle to that zone. So I have to ask the generator for effectively the first item in the list. So I'm calling next on that generator, and that's going to give me a zone. And to define this zone number, I'm going to say zone num gets zone.index. Now, one of the interesting things here is the Python layer uses zero-based indexing, where the Tecplot macro language and the Tecplot GUI uses one-based indexing. So we're going to have to add one here, because this command here is calling our macro language, which requires a one-based index. Okay, and then we also want this scalar variable, and we're going to have to do effectively the same. So say variable gets dataset dot variable. We're just going to use a name in here, temperature. And then we'll say var num gets variable dot index +1. Okay, so now we've made this script work with effectively any data set that has data with a temperature variable. So no more hard-coded numbers, so you can use a name-based system, and it's a bit more flexible. So let's just make sure that we got this right. I'm going to run it in batch mode here. Recording.py. Oh, I didn't save it. There we go. Okay, so it ran without errors, so I wrote all my code correctly, which is great. I've got my integrated result. Okay, so now let's jump to kind of the easy bake oven, and we'll show how I've modified this script even further to loop over the various Z positions, and then also stuff data back into Tecplot, so we can actually generate that line plot. All right, so the first thing I do is I always like calling new layout at the beginning. It's not really necessary because the script is just starting up, but kind of a nice thing to do, especially when you're in connected mode and want to start fresh. I also like printing out the version info. So again, this is the Python version, and then SDK version info. So this is the version of, effectively the version of Tecplot 360 that Python has picked up. You can see I've done fairly similar things here, loading the CFX data, getting a handle to the frame, getting a handle to the plot. In this, I'm just making extra sure that we are using a 3D plot. So I ask the frame to give me a handle to the 3D plot, and then I activate that. That's functionally equivalent of, in the 360 GUI, changing the plot type to Cartesian 3D. All right, here I'm getting a handle to the Z variable because I'm going to need this to define those Z stations where I want to put all of those slices. And I'm getting a handle to the temperature variable, which is the variable to integrate. And here we demonstrate the use of PyTecplot with other Python toolkits, Python modules such as NumPy. So NumPy has a really nice function called linspace, which is going to give you an evenly distributed set of floating point values between a min and max. So I'm asking this Z variable for the min and max. So I don't have to hard code the min and max of my data set. I can just query the data set for the min and max now. So again, showing the power of being able to actually do some introspection of your data and query information about the raw data that you've loaded. And then we want to, instead of using the actual min-max, we want to make sure that we're within the volume. So we're going to step in one value or one step from the minimum and step in one value from the maximum to make sure that our slices are fully within the volume. And then we're just going to print out the Z positions to show that the script is making some progress. Okay, and now TP session suspend. Let me just talk about this really quickly. So this is a Python context. So you're going to use it in this with statement. So everything underneath that with statement is going to instruct a live running Tecplot 360 to try to avoid updating the GUI. So when you're running a Tecplot 360 connected mode, after every call, Tecplot is going to try to refresh to give you an indication of what's going on with your script. To help your script run faster, you can use this trick of using TP session to suspend. So it's not going to do any updates to the GUI until you exit that context, until you fall out of this. So that's just a little hint to get your scripts to run a bit faster. Scripts will run a little bit faster in batch mode as well, but it's not nearly as pronounced. Okay, so again, we're setting up the slice. So we're getting a handle to plot slice 0. So let me just explain this slice 0 real quick. So in the slice dialog, we have multiple slice groups. So 1 through 8. Again, the Python layer is 0 based. So slice 0 corresponds to the settings of slice group 1. And we're changing the orientation of that to Z planes. We're making sure to show the slice. So this call is equivalent to the toggle here on the plot sidebar. And then we're going to loop over those Z positions that we created with linspace, and we're setting up the slice position. Because it's a Z slice, the X and Y positions don't matter. We're setting up the Z position here. So that would be the equivalent of setting this text field. Right, and then we're going to extract that slice, and you've kind of seen that before in the previous example. So extract the slice. Here I changed the mode to single zone. As we saw in the documentation, so I don't have to use the next argument there. We do the CFD analyzer call to do the integration. We pull the integrated result out, and these values are stored as a string in auxiliary data, and I'm going to convert those to a floating point value here, and then I'm going to append each one of these through the loop to my results array. So again, showing that you have access to the full power of Python here with array access as well. Because I have extracted the slices, I can optionally clean those up. In this case, I've decided to leave them around so we can actually plot those extracted slices later. And then we'll just print the integrated results. Now here again is some of the power of PyTecplot, and we're going to actually add data and stuff data back into Tecplot 360. So we're actually creating new data out of thin air. We did a couple of webinars a couple of months ago called No Data, No Loader, No Problem, which really showed how to use some of these commands. So I'm not going to dive too deep into adding new data, but rest assured you can add new zones to Tecplot for plotting, and you can modify the values. So here I'm adding a new linear zone. I give it a name and I give it a size, which matches the size of my results. And then I'm stuffing the Z values and the integrated results into there, into the Z variable that's already in the data set and the temperature variable also in the data set. And then just for posterity, for instance, if I'm running this in pure batch mode, I need to produce a result somehow. So I'm saving those results to a Tecplot ASCII file. But if I run this in connected mode, I can work with this data immediately. So let's go ahead and do that. So let's make sure that this is running connected, and we'll bring Tecplot 360 back over here. Start with a new layout, and we'll run modified. And let's just do Python-O. So this runs in optimized mode. So PyTecplot does a bunch of error checking when you're running unoptimized. So your scripts will run faster if you run with the -O flag. So you can see that I ran with Python 1.4, SDK version 2021 R1, and I have all of my results that printed out during that script. Now let's come back over here to Tecplot, and we'll take a look at the dataset information dialog. You can see I have a bunch of new slice zones, and I have a new linear zone for my integrated temperature. And so one of the great things here is with connected mode, I can not only do my work in a scripted manner, but then I can also come back and continue my work right here in the GUI. So let's just set up some plot style here. So we'll turn on the contour layer, go to temperature, and I could also script all of this as well, script all the style settings. So I've really shown you a lot of the data access capabilities, but you can deal with all the style settings as well. So we'll turn off contour for these guys and turn on translucency. For all of the slices, we will turn off translucency. All right, so there are slices. So that looks an awful lot like the introductory image for this webinar. And we'll just add a new frame here. Go to XY line, and we want Z versus temperature. And again, this is our average temperature because this is our integrated temperature zone. And there we have our final plot. Now we can get this ready for production. So again, Tecplot, because of the power of PyTecplot, has really become more than just a data visualization tool. It's become a data analysis tool. Of course, you can still use it for simple data visualization, automation. So that concludes the live demo, and we'll jump back into the PowerPoint presentation. So I hope that I've shown you some of the power of PyTecplot, some of the getting started. And I hope that you, like Jens said, we aim to make you really happy customers, and hopefully PyTecplot and a webinar like this really helps make you happy. So let's make a little plug for our next webinar, and then we'll get into Q&A. So our next webinar is on our Tec.io library, what it is and when to use it. So just a little teaser on what it is, and I teased this earlier in the webinar. Tec.io is a library which you can link into a CFD code, or you can link into any other program. We have a Fortran layer to it. We have a C++ layer to it. We actually have kind of a work in progress on our Tecplot GitHub site, a Python wrapper to this, and it will help you write Tecplot binary data directly, so then you can then post-process that data within Tecplot 360. So again, tutorials available on our website at tecplot.com/videos. We have technical support available both in North America and Europe and Western Asia. In North America, we're available 6:30 a.m. to 5:00 p.m. Pacific time. And in Europe and Western Asia, you're going to be reaching out to Jens and his colleagues at our German office. And if you are outside of either of those regionalities, it's best to reach out to your local distributor. They're in your time zone, and they're going to get you the best and fastest response. Okay, with that, we'll open it up to questions. We do have a couple of questions that came in before the webinar, so we'll tackle those first. One, can I generate a histogram with Tecplot 360? And the answer is yes, you sure can, through the use of PyTecplot. So it's not something that's built into the Tecplot 360 user interface. We do have a GitHub site, and you can see the script there. Let me just bring up web browser, and I'll show you that GitHub site. So we have a number of Python scripts available out there. We're currently working on updating the documentation and making them a little bit easier to identify and use. So we do have a histogram script here. This one should be fairly easy to use. It will, if you just run the histogram script on the command line and pass a -h, it will give you the help. You can specify the variable name that you want to do the histogram of and the number of bins. One thing that you'll notice here is it is going to do the histogram on all of the zones in your data set. So if you want to limit it to a subset of zones or a specific zone, this script is going to require some additional modification, but it should give you a pretty good start on how to perform a histogram. And you'll notice that we, again, use NumPy, another module for actually computing that histogram. And as I mentioned earlier on the Tecio slide, we do have a Python wrapper for Tecio. This is not complete, but it is a work in progress. So if you're interested in writing Tecplot binary data directly from Python, there are some examples in here and some functions that you can use to do that. Another question that came in prior to the webinar is, can a domain boundary, XYZ data, be converted to an STL file format? And the answer is, again, yes, using PyTecplot. So we don't have this script available up on our GitHub yet, but our tech support staff have it. You can contact US support or European support. Both of them have the script available. And we do endeavor to get that up on our GitHub site and create some additional documentation around that. So yeah, and this looks like a number of questions have come in during the webinar here. You want to fill us in on the action that's been going on over there?
Thank you very much, Scott. First, thank you very much for your awesome presentation. Yeah, indeed, we had some questions. So the first question is not exclusively for PyTecplot. The question is, what to do if you have an HPC and you would like to visualize the data, but you not have the data directly on your personal computer. And I would say it has to do a little bit with our webinar, the next webinar, which is about Tecio, because we have the Sizzle format and a Sizzle server, which allows to visualize on your personal node without downloading the data. That's one of the points. And if you would like to create the data parallelized, then you would use the parallelized version of the Tecio with the MPI. And the next point is, if we are speaking about to create the data in a parallel way with Tecplot, then I could imagine that you use indeed Python with Tecplot to organize this process. Scott, what would you say?
Yeah, I think you know, Sizzle Server is a good place to start. So Sizzle Server does actually transfer some data. So the way it works is really a data server. So when you're running Tecplot 360 on your local machine and connected to Sizzle Server, it will transfer the data required to do a plot. So if you're doing simple slices and isosurfaces, it's a great option for you. As soon as you do something like a derivative calculation, that's going to require the whole grid, and it's actually going to start pulling the entire model down. So you have to be a little bit careful with Sizzle Server in that case. But again, for looking at external boundaries, slices, isosurfaces, I think Sizzle Server is a really great option.
Yes, thank you very much. I just would like to add that we have a webinar which is about to use PyTecplot in a parallel way to produce way faster images, because you can simply work with multiple threads, and this would be way faster, right? Okay. Next question is, can we incorporate other macros already in our Python code? And the answer is simply yes, because there's a command which executes complete macro files. That's one option. Or another idea, maybe if you are thinking a little bit more Pythonic, what you could do is to load a macro into your macro debugger, and then you record a Python script. And if you then go step by step through the macro, then all the commands are converted to a Python script. I think this is a pretty attractive way too, if you are interested more in a Pythonic style to work with that. Scott, something to add?
No, just again, in the documentation, you can see macro execute command. This will execute a single or a set of commands. So you can see in this example, we actually have multiple commands listed in a single execute command call. And then there is also execute file, which will run an entire macro file. There are a couple of notes here, things like varset and loops are not really supported within the execute command call.
Okay.
But yeah, it can give you a way to transition from the macro language to Python.
Okay, great. The next question is pretty much related, because the question is, if you load a recorded Python macro and you would like to keep adding something to it. Example, what you're doing right now, you did it in the GUI, but can you use PyTecplot record and add to the previous recorded Python script? Well, this is one of the new questions which I didn't answer so far. Would you like to answer?
So I don't know that I'm 100% following, but it sounds like can you run like a Python script and then append to it by recording additional commands? And the answer is really no. Yeah, I think you really, when you record, it's going to record to a new file, or if you select an existing file, it's going to overwrite it. So you're going to have to append the new commands yourself.
Yeah. Okay, and one more question. This question is pretty new. Is there a way? Let me get back. Can I add to 3D plot a simple XYZ data, say with a text file, to just plot location points on the existing plots? Yes, I think this is a basic Tecplot functionality which you can do. And what you can do in Tecplot itself, of course, this is scriptable too, I would say.
Yeah, and I sort of showed that with this command, adding an ordered zone. You could add, effectively here, I just added 2 variables worth of data, but if you have other, you can simply add data using PyTecplot here. And for that one, I think I'd maybe go back to the no data, no problem webinar.
Yeah, thank you very much. Another question is, can you touch a little bit more on working with notebooks rather than Py files? I think that Jupyter is meant, right? And yes, it's possible, but perhaps you would like to spend a word about it?
Yeah, I could probably just demonstrate it here as well. Jupyter Notebook. So yes, Tecplot 360 will work with Jupyter Notebooks. PyTecplot will work with Jupyter Notebooks. So here, just add a new one and just say import Tecplot as TP, and I can execute that, and then we'll say dataset gets tp.data.load cfx axial ini001.res, execute that, and then we'll say print dataset. And so you can see now, right from the Jupyter Notebook, I've been able to load the data, and you can see that I have quite a few variables in this data set, quite a few zones. So you can do everything you can do. One thing I will note is that we found that PyTecplot tends to run slower in Jupyter Notebooks and IDEs than it does from the command line. So kind of my normal workflow is to use a Jupyter Notebook to help develop my scripts. The great thing is you can use the different cells to kind of go back and debug. So I find Jupyter Notebooks to be really handy in that way. And then once I'm happy with my script, I'll save it as an actual .py file, so I get some better performance out of it.
Yeah, great. Thank you very much. And I got notified that you exactly answered the question. The next point is there a way to write a script that works both connected or not? The answer is pretty simple, yes. It depends just that you need to load data if it's in a batch mode, and otherwise you can access data which is already there. Scott, would you like to add something?
Yeah, I think a point of note here is that you really can't switch between connected and unconnected while a script is running. The state of the Tecplot engine, so to speak, is different in those cases. But one thing that we've done here at Tecplot is we'll say import SYS, and we'll say if SYS, let's see, if -c in sys.arg v, I think it is. I might not have that right, but we'll do something like that. So if you pass a -c on the command line, it will then run in connected mode, and then you might want to use that command down here as well. So if you'd say like if not, I think there's a command to check to see if you're currently connected. So down here you might want to say if tp.session.is connected. I don't think this is the actual right command, but then do this. Right, if it's not connected, something of that sort. So yes, you can write your scripts to run either way, but you can't switch between connected and unconnected while the script is running.
Yeah, thank you very much. Great. I see that one question is already answered. Let me go to this question. There I have no clue personally. Can you use PDB for debugging? I never used that. Do you know something about it?
So PDB files are something generated by, at least I think this is what you're referring to. PDB files are generated by Visual Studio when compiling an application. We do not distribute PDB files with Tecplot 360. So the answer is no. For that one. So, if you have further questions about that, or if I didn't quite get it right, you can reach out to me. I'm referring to PDB debugger package from Python. Oh, I see. I believe so, yes. I was just working with our primary Python developer, and he showed me a debugger. I think it's what you're talking about. So the answer is most likely yes, you can use the Python PDB debugger.
Super, thank you very much. And I think the last question is already answered in the chat. The question is, I'm a newbie to Tecplot and was notified of this webinar yesterday. I noticed the session is being recorded. Where can I get access to the previous webinars and videos? Perhaps we should show that. And this was the last question, as it seems.
Sure. Let's Now this is a problem for me. Let's navigate to it on the website. Yeah, so we can go to support 360 videos, and you have all sorts of search capability here and tags. So let's look at PyTecplot. Yeah, so you can see a number of the webinars that we've done and videos that we've done on our website. Like I mentioned before, the no data, no problem series. We did the last two here, so using Python to load custom file formats. So again, gosh, one of the great things about Tecplot and PyTecplot is even if we don't have a data loader for you, Python gives you a way to read that data and stuff it into Tecplot 360. I see a new question has just come in. Will high-ordered unstructured mesh data be supported? The answer is yes, but the question is when. We do have an active research project on high-ordered unstructured data. Our CTO, Chief Technical Officer, Scott Imlay, has published a couple of papers at AIAA on the work that he's been doing. The work has primarily been focused on doing what we call a selective subdivision technique of the high order grid for the purpose of displaying slices and isosurfaces. The interesting thing about that technique is most other post-processors or most HOE code developers, in order to visualize their data, have to subdivide the entire grid, which you get an explosion of the number of elements. And so what we are doing is a selective subdivision. So we will only subdivide the cells that are in the region of the isosurface that you want to draw. Right now, that selective subdivision allows you to configure the number of levels of subdivision you want, starting at 2 levels of subdivision and going up from there. In our early experiments, it looks like for most cases, you really don't need more than about 3 subdivisions. I would love to put you in contact with our CTO, Scott Imlay, so you can discuss that more. But yeah, that's an active area of research. Yeah, and we're 3 minutes past the hour, so thank you all for your engagement and your time today. Thank you, Jens, for helping me out with the questions. Couldn't have done it without you. We'll see you all at the next webinar.
Yeah, thank you very much for participation, and goodbye.